everyone. In this video, I'm going to show you how to find the general solution for a differential equation. Okay, now in our previous lesson, we talked about the fact that a differential equation is just an equation that involves a derivative, and we already learned how to separate the variables, okay, which is the first step in solving differential equations. Okay, so for what we're going to do today, the steps are separate the variables, then you're going to integrate both sides, and then you're just going to solve for y. Okay, let's look at some examples. All right, so here our differential equation is dy over dt equals 2 times t. And so this one is pretty easy to separate. All we have to do is multiply by dt on both sides, and we'll get dy equals 2t times dt. And our variables are separated. So the next step is then to integrate both sides. So you're going to put an integral symbol in front of each side, and then you're going to anti-derive both sides. So if we're integrating dy, you could also think of this as the integral of 1 times dy. And so if I anti-derive 1 with respect to y, that just gets me at y, or 1 times y. Okay. Now, technically plus c, okay, equals, if I anti-derive 2 times t, I get 2 times t squared divided by 2 plus c. All right, so then you're just going to solve for y. Now, technically, you guys, you do add a plus c to both sides, but eventually you'll just move the constant of integration to one side. So honestly, we kind of get in the habit of just adding the plus c to the right side. So I probably would just, when I integrate both sides, I'll just go, okay, the integral, anti-derive 1 times dy, I get y, equals, and then the antiderivative of 2t is going to be 2t squared over 2, plus c, just adding the plus c to the right side. And then, of course, we can just simplify, and we'll get y equals t squared plus c. Now, this is what we call the general solution because of the plus c. Since we don't know what the constant of integration is, this is not a specific or particular solution. It's just a general solution. Meaning, honestly, the possibilities are infinite because the values of c are infinite. Okay, let's look at a few more examples. Okay, so this time our differential equation is dy over dt equals 3t divided by y. And so our first step is going to be to separate the variables. Now, to separate this one, we actually could just cross multiply. And so by cross multiply, I'll get y times dy equals 3t times dt. And our variables are separated. So the next step, we're going to integrate both sides. So if I anti-derive y, I get y squared over 2 equals, and then if I anti-derive the 3t, I get 3t squared over 2, and then I'm just going to add the plus c to the right side. And then our next step is we're going to solve for y. Okay, so in order to solve for y, I would probably start by multiplying by 2 on both sides. So we'll get y squared equals. Okay, now you guys, technically you are distributing the 2, okay? 2 times 3t squared over 2 is just going to equal 3t squared. Now, 2 times c is still some unknown constant, okay? So don't write that as 2 times c. we're just going to write it as another plus c, because we still don't know what that constant is, and 2 times some unknown constant is still an unknown constant, okay? So that's one of the key things when you're solving these equations that you want to think about. Okay, we're almost there. We still haven't solved for y, though. To undo the y squared, we'll now square root both sides. And remember, when you square root both sides, you get 2 solutions. So we got to put a positive and a negative in front of our square root. And again, this is what we call the general solution to the differential equation. In the next video, you'll learn how to find a particular solution. So if we have a little bit more information, we can actually solve for c. And in this case, we could narrow it down to whether it's the positive square root or the negative square root. But without some more information, we really don't know. And so again, this would be what we call the general solution. Okay. So you guys, that's all there is to it. It's actually pretty easy. You just separate the variables, integrate both sides, adding a plus c to the right side, and then just solve for y. And you will have it. Oh, I felt like I skipped an example. Sorry about that. Let's go back to this example. Okay, so this time our differential equation is dy over dt equals 2 times y. Okay, so to separate this time, I would probably start by multiplying by the dt on both sides, which will give us dy equals 2 times y times dt. Okay, so we're not quite finished because we haven't separated the variables yet. We need the y to be on the left side with the dy. And since we're multiplying, we can accomplish that goal with division. So what I'm going to do is just divide by y on both sides. Now, you could divide by 2 times y if you wanted, but I can just tell you it's a little bit easier if you just leave the constants, the 2, on the right side instead of moving it over to the left side. Okay. All right. So here's what we have now. We have, and personally, you can leave it dy over y. I kind of like to write it as 1 over y times dy, because in my mind it's a little bit easier when I integrate to look at it like that. Okay, equals 2 times dt. All right, so we have separated our variables, so the next step is to integrate both sides. So the antiderivative of 1 over y is the natural log of the absolute value of y equals, and then the antiderivative of 2 with respect to t is going to be 2 times t plus c, adding the plus c to the right side. All right, then we have to solve for y. Now, it's not unusual with differential equations when you're solving them to end up with natural log. So you guys, to solve for y, we would want to convert this to exponential form, okay? So remember, natural log is base e, okay? So to convert this to exponential form, or you could also exponentiate each side, okay, however you want to look at it. If you convert it to exponential form, it would become y equals e to the 2t plus c power. Okay, or you can look at it as exponentiating each side, which means we're going to make each side an exponent by adding e as a base. Okay, and then if you have e to the natural log of y, those are going to undo each other, just equaling y. However you want to look at it, you'll get the same result. Y equals e to the 2t plus c. Okay, now you guys, instead of leaving that plus c in the exponent, we're going to use our properties of exponents, and we actually did this in the previous lesson. We can rewrite e to the 2t plus c as e to the 2t times e to the c. And then e to the c power is still some unknown constant. So we actually can just replace that with a c. And then this will just become y equals c, some unknown constant, times e to the 2t power. Okay, and doing this will make solving for c later on a lot easier. Okay, so I would get in the habit of doing that anytime you end up with y equaling an exponential equation where you've got a sum or difference. Probably more specifically a sum because you're going to add c. You can always break it up and rewrite it as y equals c times e to the 2t. Okay, now we're done with the video, and we'll definitely practice this some more in class tomorrow. So, as always, thank you for watching and have a good night.